Hello students, welcome back. Now let's go to section 3, logarithmic functions. The logarithmic function is defined as the inverse function of an exponential function. So it's defined as an inverse function. So a to the x power function, that's the exponential function. Then its inverse function is defined like this. Log base a of x. And therefore all properties of inverse functions apply. What do you mean by that? Domain becomes range, range becomes domain. And then the cancellation rule. Whenever you have inverse functions, cancel each other, and then we get the original one back. So basically we are doing this kind of algebraic operation. Log a and exponential cancel each other out, and we just get x. Just like that, inverse and original cancel each other out. Exponential and log cancel each other out, and we just get x. You see the cancellation? A to the 0 power is 1. Everybody knows this, right? And if you apply that to log function, 1 can be written as a to the 0 power from this, right? So far so good. And then we use cancellation rule. What happens? Log and exponential cancel out. You get 0. Conclusion? A to the 0 power is 1. From there, we can prove that log of 1 is always 0. Remember these rules. Domain becomes range, range becomes domain. Log and exponential cancel each other out. And finally, log of 1 is 0. Graphs, okay, that's even more important. And, I have kind of graphs like these, an exponential function growing very slowly, and log function like these. And as you can see, symmetric with respect to the principal diagonal. This program is randomized, so let's run it again. For different a values, exponential going up, log like this, and so on and so forth. Let's see. Range is y-coordinate values that's greater than 0, right? So y is greater than 0. Likewise, domain, x is greater than 0. The domain for blue or exponential function is negative infinity to positive infinity. So the range for log function is negative infinity to positive infinity. Yeah, this thing grows up very, very slowly, but goes to positive infinity. So by looking at the graph, you can answer this question too. Domain becomes range, range becomes domain. Now when a is less than 1, we get this kind of exponential logarithmic functions, but we hardly consider these cases. We hardly consider these cases either for arbitrary a values. 99% of the time, we're going to consider the natural logarithmic function. Natural exponential function blue, where the base is Euler number 2.718 something something, an irrational number that has no ends and no repeating pattern. And inverse function is the natural logarithmic function, which we write as ln. Log base e, that special case, we abbreviate as ln. So this expression, let me get back to black. Yeah, gray. This expression, replacing a by e, is hardly used. We typically use ln for natural exponential function. Oh, excuse me, natural logarithmic function. So those are properties of natural exponential and natural logarithm, and also arbitrary exponential and arbitrary logarithm. Let's see, do we have some examples, some functions? Oh, that's a bit harder. Plot a graph and determine all intercepts. Oh, these are too hard. I mean, these are appropriate for STEM algebra, but for business algebra, I think this is overkilling. Let me show you some graphs. Oh, yeah. Even graphs are really intimidating. Oh, no. So, let's not worry about the final example. That means we don't have a lot of examples. Okay, so let's have a brief review and then complete this lesson video. So we begin with the exponential function a to the x power and take the inverse. That's a log function. And because of that, we have all those properties of inverse functions. Domain becomes range, range becomes domain, and that is reflected on the graph. X becomes y, y becomes x. And then the most important computation, the cancellation. And how do you kill off the exponential? By taking the log and crossing out. How do you kill off the log? By taking the exponential and crossing out. And finally, this rule, a to the 0 is 1. So log of 1 is 0. All right. We're going to talk about log rules and log equations in the next video. And that's it for the first 1/3 of section 3.